Classifying reactions, Part 1. The classification of reactions is a method by which we can look at different reaction types and characterize them according to their natures. All chemistry that we deal with wants an organizational scheme as much as we can accomplish for all things that we study because it makes the conducting science much more effective. We classify reactions by their characteristics, and there are multiple ways that we can do this. Some reactions are named, others are not. For example, in organic chemistry, there are named reactions like the Grignard reaction that have a specific name to a particular reaction. However, without a name, we can still classify reaction by what type it is. There are two ways to classify reactions. We classify them by what the atoms do, in which we consider the combination or the rearrangement of atoms as it occurs within the chemical reaction. And there are four basic types of classification by what atoms do. The problem with classification by what the atoms are doing is sometimes they can be difficult to recognize, and there can be multiple combinations of what happens, such as replacements and decompositions and things occurring. Most reactions can be classified as multiple different types of reactions. The other way of dealing with classification is classifying by type. Now we say that and it sounds a little generic, but what atoms do is one specific way, by type is another specific way, although technically speaking what atoms do is a type of classification. But we're dealing with two separate classification schemes when we say by type and by what atoms do. Classifying by type considers the nature of the products and reactants rather than the combination or rearrangement that occurs, and looking at them as a whole. And there are four classes, again, of classification by type, but then there's also a subclass. Generally, classification by type is easier to recognize than classification by what the atoms are doing, because we're looking at specific natures of products. Classification by what atoms do, the four basic types are combination or synthesis reactions, decomposition reactions, single replacement or replacement reactions, which are also called displacement reactions, or double displacement or replacement reactions, sometimes called metathesis reactions. When we're looking at these four different types, we can write a generic formula to describe what occurs. For a combination reaction, we take two things to create something else which is more complicated from the two things. For decomposition, we'll take one thing and decompose it or split it apart to make multiple things. A displacement reaction occurs when one substance will take the place of another substance in a chemical formula. And a metathesis reaction occurs when two substances trade partners, where one component of one substance and one component of another substance will swap places in the chemical formula. Now, looking at these individual reactions, a combination reaction occurs when two or more things combine to make one thing or more than one. But in general, we're making more complicated products from less complicated reactants. The general schematic, A plus B yields AB. So the products will be more complex than the reactants are. They can be elements or compounds, or a combination of elements and compounds. For example, we can have two or more elements combined to make a compound, for example, hydrogen and chlorine to make hydrogen chloride. We can have an element in a compound combined to make a larger compound like phosphorus trichloride combining with chlorine gas to make phosphorus pentachloride. Or we can have multiple compounds combined to make a compound, calcium oxide combining with carbon dioxide to make calcium carbonate. In a decomposition reaction, we'll take one thing and split it apart to make multiple things. The generic formula for a decomposition reaction is AB yields A plus B. In a decomposition reaction, the products will wind up being less complex than the reactants are because they're being decomposed, they're being split apart. The decomposition reaction can produce complete elements, completely compounds, or a combination of elements and compounds, analogous to how a synthesis or combination reaction can use all elements, all compounds, or a combination. Essentially, a decomposition reaction is the opposite of a combination reaction. Examples of decomposition reactions: we can have two or more elements being formed from a compound. For instance, water is split to make oxygen and hydrogen as its component elements. You can create an element in a compound from a decomposition reaction, like ammonium nitrite, splitting to make nitrogen and water. Or you can make two or more compounds from a compound as it decomposes. Calcium carbonate can be split to make calcium oxide and carbon dioxide. Now, displacement reaction is a reaction in which one thing takes the place of another, replaces it. the generic formula A plus B, you see A and B switch places where A is now partnered with C on the right-hand side, and B is by itself. In these sort of reactions, a free substance becomes part of a compound. This is usually the combination of an element and a compound, and A and B are generally either metals or halogens. A is the more active of the two versus B. In these sort of reactions, an oxidation state will change for both A and B. In a metal, A and B are the cation. In a halogen replacement, A and B are the anion. Examples of the displacement reaction: for a metal, zinc can displace copper, where zinc as a more active metal will take the place of copper in the reaction, forming zinc sulfate and copper as free elemental copper. The halogen replacement, chlorine as a more active element than iodine can take the place of iodine and sodium iodide, making sodium chloride and iodine as a solid. A metathesis reaction is one in which we have two substances which will switch places in a compound. The generic formula AB plus CD yields AD plus CB, where now A and B have swapped, where A is now a D and B is now a C. In these, we have cation-anion pairs which exchange with each other. There are always two compounds involved in a metathesis reaction. Usually a metathesis reaction is driven by the loss of the product, for example, the precipitation or the escape of a gas or the creation of a molecular substance from ions, and the oxidation states will stay constant in a metathesis reaction, whereas with our displacement reaction the oxidation states change. Example of a metathesis reaction is the reaction of sodium chloride with silver nitrate to form sodium nitrate and silver chloride. Here we have sodium with a 1 plus oxidation state and chloride with a 1 minus oxidation state, silver with a 1 plus, nitrogen with a 5 plus, and oxygen with a 2 minus. And on the other side we have sodium still as a 1 plus, nitrogen still as a 5 plus, oxygen still as a 2 minus, and silver still as a 1 plus, and chloride still as a 1 minus. So none of the oxidation states of the individual atoms change left to right.